more into the Schwarzschild proton and Nassim Haramein's work and the relevance with your own?
Dude, I even tried to reach out to Nassim because once I plugged that thing in and noticed, I mean, the whole idea, look, again, an engineering mind, Jeremiah, you guys know the guys that are like engineers at heart. I mean, so I immediately, when I saw that it goes for a Planck and also as well as the horizon scale, I said, what about everything in between? So why not try the proton? And when I saw that when you put in the mass of the proton, 10 to the minus 27 kilograms, it gives you a reference length on the order of 10 to the minus 54 meters. It doesn't take a freaking quantum physicist to realize that's the Schwarzschild radius, 2 GM, 2 big GM and divided by C squared, 10 to the minus 4. So in other words, it's super force that makes the proton act like a black hole. So this thing will never really decay if left to itself. That's why, they're saying that the decay time is extremely high. And Dave, the physicist, how high is it? It's very high, like 10 to the 34. I remember.
Well, I mean, we think the proton could be stable. There's grand unified theories that predict it to decay, but it seems to be stable.
So it's stable. There you go. It's stable because it's acting as a black hole because of the superforce. Boom. So what if other particles act the same way? Hence vortex dynamics. We're talking about going, from the 10 to the minus 15, bum, 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 boop, at 10 to the minus 54, something. We're not talking about space-time singularities here. We're talking about quantum bounces, hence super bang. The idea that at a super density, we're seeing something that's analogous to the physics of a supernova. How does a supernova work? Once the fuel runs out, gravitation collapse, boom, to what? 10 to the minus 15 meters. So you talk about 1 femtometer. At that particular scale, what operates? The strong nuclear force, right? Okay, well, what happens? Core bounce. Boom, that thing explodes, right? And the density it talks to is like 10 to the minus, no, 10 to the 14, 10 to the 4 is huge, 10 to the 14 grams per centimeter cube. Well, I am arguing that at a super density of 10 to the 90 kilograms per centimeter cube, so 10 to the 96 kilograms per meter cube, something like that. My math could be off, but anyway, something like that, huge, we're talking about big. At that, because of the 10 to the 44 newtons, so we're talking about the super force acting at that 10 to the minus 35 meters at the Planck scale, it undergoes, boom, the Ashtekar bounce. The whole idea of a quantum bounce. That's what, so there are no space-time singularity. It never goes to zero. It goes to the Planck length. I'm just putting it out there. So, may sound crazy, but what if I'm right? What if the super force creates a super bang and eventually, because of the nature of the cosmos, according to Anthony Peratt, more than 99.9991%, we're talking about hydrogen plasma, correct? What if, because of the nature, for example, we have what? 100 billion neurons, right? Supposedly there are 100 billion galaxies that each have 100 billion stars. You see what I'm saying? It's almost like a neural network, man. We're talking about a possibility of a super intelligence. Super force, because of the super density, super bang, super intelligence. Boom, the triarchy of creation. There you go, Michio Kaku. Does that beat your God equation?
What do you?
I'm just trying to be jocular.
All right.
No, it sounds very much like the Boltzmann brain ideas.
Yeah, I was just going to ask you, what do you think about Wolfram?
Oh, dude, this guy is so. I think he's so brilliant. I mean, I would, if I understood some of that math, dude. The truth is, I don't have, for example, the mathematics knowledge of, for example, Jeremiah Pop, I think, is more like me, but maybe I'm wrong. Maybe your mathematical knowledge is as good as Michael Peron's, is as good as Dave's over there. I mean, Dave, the physicist math, oh my God, I tried to follow one time. I thought I was going to deliver. I'm not kidding you. Talk about pregnancy of mind, man. Oh, speaking of which, listen, I would love an MMA type where, you know, a couple of us, you know, that supposedly do not operate in the mainstream, a couple of us go in a quote unquote, and then, you know, a cage of some sort, but the whole thing is televised, and we go with some real credible physicists out there. You know, we talk about Seth Lloyd, we talk about Tegmark, David Gross, why not Stefan Alexander, Brian Keith? You know what I mean? Like some
Tyson
heavy.
on there.
I
too.
love the idea of a physics battle, MMA style. Heck yeah.
Don't forget Maldacena. He's highly mathematical. That ADS equals CFT. He forgets that we live in a de Sitter space, according to Eric Vallinda. And all. Anyway, Eric Vallinda too. I would like to see how he behaves so close to Maldacena. But anyway, you know, we might get a buddy in there. But the whole idea is an MMA type, like combat of the minds. It'd be so cool, man. Dude, it might
I
take
love
away
that
from
idea.
You know what I'm saying?
Mixed mental arts.
I'll play the Joe Rogan and be the referee announcer.
It might be the biggest show in the history of shows. I guarantee that thing would attract a lot of people. Because look, there are a lot of Joe the plumbers out there interested in physics.
Well, they had
But
Crossfire
of course, they
for
don't have
politics, so we should have like a Crossfire for.
And they
for
don't have
physics.
his knowledge. They're not allowed to publish in these great journals that have great impact factors. You see what I'm saying?
Yeah. I know you got your.
Sorry about that. I'm going off the deep end. Yeah.
So, did you the 3-pager you made, this is public now, I suppose, or
it's a preprint. Yeah, I can publish it. I can publish it. Nobody.
So,
I even sent it to
section 4. I was curious what you meant. I was curious what you meant by applying equation 1 to equation 2 in section 4. You had your x on the order of y, y on the order of z.
Equation 2 is the Schrodinger equation.
Sure.
Now, Dave, the physicist, can attest to the once you take the Schrodinger equation. I'm not talking about Dirac equation, Dirac notation here, because oh my God, that gives me a headache. I'm talking about simple stuff. You take Schrodinger's equation, okay, which is really a linear equation. You take that, you combine it with E equal m whatever m dot c square plus p square c square. You know what I'm saying? Like the whole Pythagorean thing, E square. You know what I'm saying? I'm talking about special relativity. You combine special relativity with the Schrodinger equation, you get the Dirac equation. So I'm saying whatever applies to the Schrodinger equation because of the linearity of the thing will apply to the Dirac equation. And when you actually write the Dirac equation out, you see the terms resemble that of the Schrodinger equation with the terms added in for special relativity, for the relativity.
So I'm a little,
but it's a little different.
Confused about what specifically you're doing.
No, let me explain. Let me explain. If you look at the equivalence of the terms, hey, we have a really young physicist in here. Hey, brother. Is it a brother or sister? But it sounds anyway.
Yeah, that's my daughter.
Dude, they start young, brother. Hey, oh man, I tell you, she's gonna be brilliant, brother. Anyway, I'm trying really hard to push my daughter toward math and physics, and I'm trying a little too hard, and I think she like hates it because dude, you should never force a person to do anything, especially the ones you love. But anyway,
you have to trick them in through video games and stuff, like educational ones.
Dude, almost. STEM kits. There are so many good ways for a kid to get their hands on stuff. When the mind is young and it's learning, you've got to give them a chance to play with it. They've got to play.
Michael, I promise we'll return to your question. I promise. But go ahead, Jeremiah, because that's important. Again, philosophy. Hey, brother. What's the flavor, by the way?
Well, it was lemon cola. It tasted like soda, but I've been putting this just basic mint flavor in there. So mint with nothing but glycerin. It burns nice and clean. It's just a plain old cheap nicotine delivery system, but it works pretty well.
Hey, as long as it gives you a little boost of energy. Yeah. But anyway, go on with that, because philosophy, again,
the philosophy of the young mind, right? When a kid is learning, we can't just try to dump tons of ideas on them and convince them that they're important. This would be like, word questions
You're
in
right.
class. We're told that we have to know these things, but never told why we'll need them or when we'll use them. We'll give a kid a kit. Let them put their hands on something easy to assemble. And all of a sudden, science is no longer a task. Physics is no longer a career. Now it's play. It's just play. And so their minds naturally learn because you've let them play.
Yes.
And there are plenty of kits out there, STEM program kits specifically for this at many, varying age levels and talent levels for just getting into it. But we've got to let the kids play. Otherwise, they're not going to have any reason to want this.
Exactly. That's good child psychology, bro. But in a way, you can call it philosophy of the mind. I mean, that's what psychology really is. It's a type of philosophy. Jung was Freud's student, correct? I think so. So truly, psychology it has its roots in philosophy. Am I off?
Yeah, there's some really weird roots too, because like Freud wrote like pretty much the whole background of psychology, and he is a complete psycho weirdo who assumed all people think and process thoughts like he does.
Yeah, I studied Carl Jung, so.
Young was a student, though. They diverged, but
they were the Aristotle and Socrates of psychology, because they had such similar starts, but then such radical separations.
Yeah, let's not forget that before the term electrical engineer ever existed in the twinkling of anyone's eye, electrical engineers were called philosophers. They were the same thing, and so those good old boys that play with the influence machines, hand cranked and otherwise, they were philosophers. They weren't electricians or electrical engineers.
You know what popped to my mind? Eric Dollard. Dude, again, Joe the Plumber, someone that doesn't have the so-called quote-unquote what they interpret as the right pedigree. But dude, you listen to the ideas of this man and what he has to say. Especially there's one guy out there, man, I would have never known of him. And I started to study about Charles Proteus Steinmetz. Holy. I wish I can say the word, but anyway, I won't. You know what I'm saying? Wow. Dude, Steinmetz, you remember how he was structured, but what a giant. Isn't that interesting? How
I'm going to pull up one of Steinmetz's works here, actually, see if I can get this on screen. A really good diagram.
What he has to say about transients, waves, oscillations, remember? That's important, brothers. Look carefully what Steinmetz has to say about
that's actually out of the book that I wanted to pull this diagram from. You have the equipotential field that shows up. It's not the electric field. It's not the magnetic field. It's the equipotential field, which means this is the point along the intersection of the magnetic and the electric that is equal in stress energy density for that local space, acknowledging a more complicated interaction of electromagnetism with gravity.
Is that counter space?
That's what Dollard would call counter space, or where it happens at least.
Right. And Michael,
Terrific.
I didn't forget about you. Brother, look carefully at the equivalent. So I'm sorry to interrupt. We'll go back to this because I think Eric Dollard should be looked at carefully. And also all the stuff, the way he's been able to bridge all these people that for some unknown reason, history has forgotten. Anyway, we'll go back because they have to. Steinmetz was a genius, a total freaking brilliant genius. You know, there are pictures of him close to Einstein. You think Einstein hanged around who loses? But anyway, let's go. Let's go back. Right. So basically, look at the Schrodinger equation. You know, you have that IH body, you know, the psi dt, all that stuff. You know, I can do it, but you know, I'm not as mathematically apt as the one over there in the corner. You smart. His mathematics freaking, oh my God, it gave me a headache just looking through one of his slides. Anyway, I mean it, Dave, just one. Oh, okay. So look carefully at that Schrodinger equation. You know how if you just do like a simple, you can call it like a scaling, but more of a dimensional analysis, but don't replace it with like meter per second square, all that crap. Just think of it as, how should I say, like parameters. Maybe it should be called parametric analysis rather. But anyway, so if you do a little replacement, you can see that when you take, so all those terms are equivalent. In other words, from a physical perspective, they all count. That's what I mean by equivalent. I don't know if I'm right
of energy.
using the right terminology. I mean, from a mathematical standpoint, I could be like talking kindergarten language, but I'm trying to get to the physics of it, the Dollard way. This
Right.
Okay. So all those terms are equivalent. Okay. So when you take if you take like one of the term and you sort of equate it or say it's on the same order with another one of those parameters, E equal h nu comes out. Boom, Planck's equation. You do another one, the lambda equal h bar divided by mv, right? The Broil comes out. And then when you do the one, I think term 3 and term 2, when you equate them, from a point of view of physical equivalence, I don't know what to call it, order, man, whatever you would choose to call it, order of importance. You can call it order of importance. When you do it like that, what comes out is the superforce. Right out of
Okay, I get you now. I get you. So x, when the total amount of energy is proportional to mc squared, you have particle-like behavior. When your total amount of proportional, I should say correctly, when most of your energy is in the mc squared term, then it behaves like a particle. When most of your energy is in the p squared term, then it behaves mostly like a wave. And then when the
d sub
mc
x,
squared and pc squared are similar in
remember
magnitude.
Remember the way Penrose refers to that? It's like a rest energy of the, right? But the rest energy talks to what? To what's there, to an energy gradient. That's how you get the superforce, by considering an energy gradient at the Planck scale. And boom, the superforce comes out.
So, and then the notation here is just a little small gripe, but the notation's just slightly sloppy. It's you have V over LR, which
I'm a sloppy guy.
I assume
maybe
you're
maybe
like,
what I
about the Planck length.
One of you guys, the smart guys over here, that physics pedigree, Dave, maybe we should cooperate, write a paper based on this, and then we can put it to archive, because I know if you got the right sponsor. So I can. Do you know I can't even get a sponsor to put my paper on archive? That's how bad it is.
I mean, everyone. It's like that for everyone. I mean, like you got to understand the culture of what's happening. I mean, that's very common. So it's not like you're getting singled out. You're getting treated just like everyone else.
Yeah, it's rough right now.
There's
huge resistance to change always, right? It's that human mentality that you have to defend like the current paradigm, and that anything outside of it, right?
Archive.
And if you win
human impedance,
university that runs archive. I mean,
so anyway, so when LR is of the Planck length, then you effectively you get a differential from that, because the
energy gradient
you can have.
Right.
But you're taking Schrodinger's equation, which has nothing to do
in the Schrodinger equation. What is the Schrodinger equation? It's really the coupling of Planck's energy with the Broil's idea of the electron wave function, whatever you want to call it. And the superforce is in there, because that potential of that particle is in there. That's why the superforce is so freaking important.
No, Schrodinger's equation. Schrodinger's equation is non-relativistic, and it has no gravity. The superforce involves only G and C. So you're just putting in the Planck length and then just playing dimensional analysis to get whatever you want out. I mean, it's not. That's why.
But
people won't accept this in a journal.
But I'm not playing with it. I'm not playing with it, Dave. I'm not playing with it.
I'm just saying that the potential energy, the superforce is not in the potential energy of Schrodinger equation. It's just a fact. No, it's not there.
With anything. It's physicality.
I'm just saying that the potential energy in Schrodinger's equation has nothing to do with the Planck scale. It's simply.
But when you write it as an energy gradient at the Planck scale, all of a sudden the superforce comes out.
Right. If you plug in the Planck scale into quantum mechanics, you can get the Planck scale to come out because you plugged it in, and that's why you're playing games.
Well, what he's kind of, I think, saying is that if you look at that potential
term, the superforce operates at the Planck scale.
Superforce.
Go ahead, Michael. I'm sorry to say, but the superforce operates at the Planck scale. That's why I put for that reference length the Planck scale, the GH divided by C cubed. Okay, but it's L squared, you know, that L squared term. So it's just, anyway.
You don't need the Schrodinger equation for your statements. I mean, you're more interested in quantum field theory. As you're saying, it's all about gravity and quantum field theory. So I just thought that bringing in the Schrodinger equation was kind of...
I was just trying to show that you find it. Just like you find E equal H nu in Schrodinger.
You find it, but other physicists won't find it. I'm just trying to articulate why.
You're saying that he's just recovering it because he plugged it in, right? Is that?
Yeah, I mean, he's essentially taking Schrodinger's equation and then trying to put in the Planck length.
But I'm not plugging it in.
Well, I'm just saying Schrodinger's equation doesn't have g or the speed of light in it, so you have to do something.
It doesn't matter.
I mean, it does matter. I mean, it's the equation.
No. Think physically. Don't think mathematically. I know you're highly mathematical. Think physically now. Totally physically. That reference length, why am I plugging in the Planck length? Because I'm saying that the superforce acts at the Planck scale, hence at the Planck length. That's why I'm plugging in the Planck length.
But that has nothing to do with Schrodinger's equation.
But no.
And that's your starting point.
No, the superforce has no intuition as to why it's c to the 4 divided by g. It comes out of the Planck length being plugged in as a reference length. That's
so this B term we're talking about.
I thought you defined as the Planck force. I don't know what this thing is.
So the B term is a function, right? So are we plugging in V like as potential in units of potential energy in some sort of integrated form over that small volume or small length scale, or what's this equation saying really? Just trying to make sure I'm understanding.
One day I may be able to explain it better, but right now all I'm saying, look at the equivalence of terms. I'm saying call it an equivalence based on order of importance. So every one of the terms in Schrodinger's equation is equally important, okay? Based on that, when you write it down from a parameter point of view, make sure that the dimensions stick, okay? When you take term 1 equal term 2, something like E equal H nu comes out, or term 1 and term 3, okay? Something like E equal H nu comes out. The energy, you know, based on Planck's whatever constant with a vibration fluctuation. Then when you put in the reference length as lambda based on, say, like a wavelength, the Breuil stuff comes out. When you equate, you see what I'm saying? And then when you finally put in that reference length as Planck length, based on this equivalence of importance, whatnot, the superforce comes out. All I'm saying.
Where do your units for V?
You didn't need Schrodinger's equation.
How are you treating the superforce? If the superforce was purely classical, like it's shown in GR, it should not come out of Schrodinger's equation. That's my argument. But it does. Why? Because it's also microscopic. It's also quantum in nature. Even though it doesn't have the H bar. This was Abba Ashtakar's beef. On Kurtz, when Abba Ashtakar came on Kurt's TOE, you can see that episode. Google it and you'll see it. Kurt actually asked him, "What do you think of the superforce?" And he said, "No, it's interesting, but it cannot be fundamental. Why? Because it doesn't have H bar in it. It's not quantum." Not true. That's what makes it so beautiful. That's what makes it so special. It's that thing because it doesn't have H bar in it. But remember, the super density is C to the 5th power divided by about like big G square H bar. So the super density is the one that's quantum, that the super force operates on to create the super bang. You see, that's where the quantum aspect of it comes in. When I'm trying to say the super force acts everywhere, at every point in space-time, at the Planck scale. That's all I'm arguing for. Maybe one day.
I'm just trying to understand the argument, though. So V over LR, you have length scale, and then
someone that has better mathematics to express what I'm trying to express there. But there's no way. You cannot convince me that out of Schrodinger's equation, when you do equivalence based on order of importance, first Planck's energy equation comes out, then de Broglie's lambda, the electron, whatever wavelength comes out, and then the superforce comes out. You can convince me that's what's the word I'm looking for? That's see, I'm lost for words at times. So come on, someone help me.
Memes here has a question.
Jeremiah, what am I looking for? What's the word I'm looking for?
May I attempt to steal Dr. Pius's, Brother Pius's opinion here for a second? If Jeremy could share my screen for just a moment, just because seeing some visuals rather than like laying off all these different my screen down below. But basically saying all these words, G, big G over this. I'm a very visual person as well, so I'm a noob. So I just go to Wolfram Alpha. I type in Planck force, aka the super force. Okay, as we can see, we have our C4 over our big G, speed to the fourth by the Newton gravitational constant. It gives us these numbers right here, 10 to the 44 newtons there. All right, and then we take equation 1. We plug in. You can literally just on Wolfram Alpha, like just plug in just natural language these terms. Planck mass times c squared, so just carry it up to the second, divided by the Planck length there. We subtract out just mass of universe, so we have the universe mass, ordinary matter that we're trying to account for, times c squared, speed of light squared, divided by the radius of the observable universe as we know. And it is very interesting. It does come out to be very close to the magnitude, about 0.7 there, the Planck force, which is interesting because if we're going to try to account for perhaps some dark mass effect, whether that's a dark matter particle, a neutrino, a black hole, anion, whatever flavor it might be there, that is an interesting thing. So I believe that what Dr. Pius, the claim is, and part of this maybe is a bit of a mistranslation here, is very often if you're making a claim, I feel the way you wrote the paper, sir, is you're kind of saying it's evident there. And it might be. It might actually be the truth. I don't know that, but very often from what I've listened to Professor Wolfram in a lot of his lectures and live streams, he'll say, the claim is this. So let me try to restate this. So the claim is that there seems to be a relationship on the very large, utilizing the superforce, the Planck force, because there does seem to be maybe some correlation there with what might be going on the very large.
But that's why I didn't use the equal term. I used that squiggly line meaning on the order of. Boom.
Right. So
and
that's what's this.
Don't forget there could be that 8 pi in there that we don't really know. That 8 pi is essential, and I think it talks to a geometry. There's some geometry, there's some physics going on. That 8 pi should be looked into. That 8 pi maybe in there. In which
wait, we're getting there. I'm sorry to cut you off, sir. But when you take, as you were saying earlier, 1 over the Planck force, you get all these crazy numbers here. But the one popped out. I'm like, the Einstein constant from the C4 convention. So I explored if there was perhaps a geometric representation of this. And I'm like, oh, that last number was a 9. That's an 8 followed by an 8. That looks like 1 over 8 pi. I mean, that's pretty neat there. So, I mean, there's cool stuff here. Do I know it's right? I don't know. I just feel like we should give a fair shake. And to be fair, if you are putting terms in here, I believe the claim that you're making that if you construct it, the Schrodinger equation in a particular way, you've made some observations. And again, it's very often the Schrodinger equation is for like ground state of hydrogen or whatnot there. And we believe it works to the best of our knowledge. And then getting past there is very difficult.
It's a fundamental equation, but it shows reality, shows physical reality. All I'm asking is if Planck's energy comes out of it, if de Broglie's wavelength comes out of it, and the superforce comes out at the Planck scale, that cannot be circumstantial evidence or whatever you want to call it. Hey, Jeremiah, come in and help me, brother, with a better word. Come on. I need a better word.
If it emerges under the right conditions naturally, then what we need to do is correct the math to match the experiment, plain and simple.
I need better explanation of the math. Mine is very rudimentary. I need, someone of their Dave type.
It's not a coincidence. It's no coincidence.
Thank you. That's it. That's
well said.
Crypto Alchemist. That's right, Crypto Alchemist. It's not a coincidence. That's what I'm saying.
Can I jump in here real quick?
Yes.
Sal, so one of the things about your paper and your theory that I think would just supercharge it is to find some sort of observation in existence that your model correctly predicts or even improves upon. What I wanted to say was the squiggly somewhat equivalent to 0.770% of or whatever. If you can find that difference there that brings it 1-to-1 to whatever the cosmological observations are.
What are they doing now? They're doing James Webb crap. What if they find something that the radius of the observable universe is blah blah? Then that will tell you the exact mass that. You see what I'm saying? Then you'll see.
Or it'll help improve upon your model. See if you're close but not quite there, and then you look out at the observation, you're like, oh wait, I'm just like Einstein. I'm off by a factor of blah. I need to incorporate that into my thing.
Brother, whatever you do, please, man. Einstein was like right hand of God. Please don't compare me with that. I'm a guy just trying to be heard. Okay. So never compare me with a big man.
I'm saying the cosmological constant that he had to include in order to make it work. Yours might require a similar modifier.
Yeah, man, Dalit. We gotta come back to Eric Dalit. Another one that because of his pedigree is not being looked into. What the hell, bro? Is this what it's all about? You know what I'm saying? I mean, why not be given a chance?
That man is single-handedly keeping the legacy of RCA alive.
I would have not known crap about Steinmetz's work if it wasn't for Dalit. A lot of people would have been oblivious to a lot of things out there. And you got to look at Dalit's mathematics. This is what I love the man, because it's simple and it talks to great physics, great physical understanding. And this is what I'm talking about. You do not need complex, abstract mathematical acrobatics to understand great physics. That's my argument. Unfortunately, a lot of people say that such complex mathematics is necessary to be considered as a great physicist. And I tell you, that's a bunch of gobbledygook. That's all.
Yeah, I mean, Faraday is an example, right? I mean, so you don't need mathematics to get the principles, but eventually you might need mathematics to solve some of the problems.
He never wrote one. Yeah.
Well, this is up. I just wanted to mention, like, where Eric Dollard really started with a lot of his major discoveries was with this specific book. You'll hear him talk about this book all the time. This is what your intro page looks like.
Yeah,
going through this book, it is loaded with a ton of diagrams. Let me just
and we
scroll down into the meat and potatoes. So,
if it wasn't for Dollard, this book would have been lost.
No
a great book would have been lost if it wasn't for him.
Like curve charts, relationships between field forces.
Was unbelievable.
Yep. Yeah, it's unbelievable. So yeah, definitely. This book is free on archive.org. So I'm not going to drop a link here, but if anybody else wants to, that's fine. But yeah, this is free on archive. So grab it if you want to research this stuff. That's all.
That's the background that we use on the channel right there. Is that image, figure 9 right there.
The Steinmetz diagram.
Unbelievable, dude. Dude, man, there were a lot of them. Now that I think of it, Jeremy, you know, because you put a lot, dude, you've done a lot of research in this. How many people are we talking about that have been dismissed by the history of physics completely? As you know what I'm talking about. A lot, right?
There's a number. I mean,
sorry to interrupt. I just have
physics, but related fields too, like Nobel Prize in chemistry. I think in 2011 was Daniel Schechtman, and he was called a quasi-scientist for his discovery of quasi-crystals by the leading chemist in the world at the time, Linus Pauling. So there's been so many great discoveries that have been called pseudoscience, have been ridiculed and laughed off the map. So that's why
they have to come out of the fringe, right? It's got to be out of the box thinking for it to be a new groundbreaking or shifting idea, a new paradigm. It can't be, by definition, anything that's new paradigm can't be from the old paradigm, right? And I just wanted to state your background actually was created by me and Jeremiah and Paranoid American by AI. Jeremiah was entering in some extremely technical questions to the AI, and it generated this background that we're using, which is the same as Steinmetz diagram.
I think I was actually asking him about equipotential fields on that show, so yeah, it would have been.
So Steinmetz believed a lot in non-equilibrium phenomena. Look what he had toward the end of the little book. Man, I love these little books. I tell you, every one of my books that I have are little. I don't have anything big. Even, the biggest book I have on quantum theory is the one Dave knows. I bet you, Anthony Z, Quantum Theory in a Nutshell. Ain't that a beautiful book?
I didn't even hear about that book. Sounds like
a good conceptual book.
Understood, but anyway, yeah.
It's not very helpful for homework, but it's good to understand the quantum field theory.
Feynman's volume 3 in his lectures. I tried, but Z is a master. Really, he's able to. Anyway, and I'm not saying Feynman was. I mean, Feynman's again. If Einstein was on the right side, this dude was on the left side, so not bad. You can go a long way with such archangels. So yeah. Anyway, that's why it really pisses me off when people try to prove Einstein wrong. It rubs me the wrong way, and that's why I like that archive. It's the way it is, because I'm sick and tired of hearing Einstein was wrong. Even Michio Kaku said it recently. Why Einstein was wrong? What? I want to say it, but I won't.
It's just memes, It's just a mimetic saying. Yeah, like everyone wants to be smarter than the smartest guy, like whatever. It catches people's interest. That's part of the problem with all this, is the Tower of Babel. People have their words that mean things, and they pigeonhole things because of that, and that creates a lot of problems.
Why try to bring the grades down? Why always try to bring? This is like, remember, Jeremy, that the crabs in a pot thing, one crab does, the other one's pulling down. You know what I'm saying? It's like, what's going on here, man? Dude, if we must re-engineer something, we should re-engineer human nature, because it's human nature that's been responsible for all the crap we're dealing with today, maybe more. Anyway.
Well, unfortunately, the best of wisdom comes from successful adaptation to suffering, but that's sometimes how it is in life. What was I going to say, though? Yeah, I mean, to some extent, you don't necessarily need the mathematics to understand and be a great physicist, but you will need some level of mathematics to efficiently explain that math and physics to other people. That's the important thing.
That's why I need a pedigreed physicist to help me rewrite this paper and to get and if he wants to publish his first order, because I know it matters, like in the field it matters, but I need someone like that, so I can co-publish with, because otherwise this idea will never be seen. That's the bottom line.
I think if you just focus, like the Superforce paper has like 5 sections, and they're all. I mean, you claim that they're related, but to me, they're almost independent sections. And I think it would make more sense to just focus on one topic and explore it in more detail. And like I was criticizing you for using the Schrodinger equation, but when I originally looked at your Superforce paper first, and I was just like, why is he not talking about 0-point energy? Why is he not like it's about quantum field theory? But then I went back to your 2017 patent, you were talking about it with more detail there. So I think. You're trying to make it so simple and not go into math, which might be good for kind of a lay audience, but it's just not really appropriate. If your desire is to get a paper published in a journal, then you kind of have to speak to their language. And so, I mean, I think that you could sort of reformulate that first idea that the memes of destruction was talking about. That was in section 2, not section 4. So yeah, I mean. I did actually write up like 5 pages of notes on it. I mean, it's pretty critical of what you're saying, but I reformulated your.
So maybe you and I should cooperate. Dave, the physicist, you and I should cooperate and get a paper out. maybe try to put
I'm
it
at least willing to share my ideas with you.
Listen, I wouldn't mind if you were a first author, not at all. I just want to get this idea out so it's looked at rather than considered garbage.
That
right
sounds
now,
like a great team up, honestly.
No,
David has one of the brightest math brains I've ever seen.
Look, I've never cared who was first author, second author, third one. I'm sick and tired of that shit. I need these ideas out there. We need these ideas out there for others to take them and run with them and do greater things so this civilization can progress, so we can break the shackles of Earth and be done with this rocket crap. It's 110-year-old technology. It's based on Newton's third law of motion, for goodness sake. When did Newton live? Freaking, what, 1600s? Please, man.
Oh, man, I know. Right there with you.
mean, liquid hydrogen, liquid oxygen. Sorry, I'm going off the deep end, but this really rubs me the wrong way. Nicholas Tsiolkovsky came up with the rocket equation, like late 1800s, like circa when Heaviside came up with his version of Maxwell's equations. We haven't progressed since. The only way to transport a craft through space-time is to throw. Oh, I want to say something.
Yeah, I know, man. That's literally why.
NASA and propels. Please, man, come on, Elon, you can do better.
That is literally why we started at APEC.
You can do better.
The Alternative Propulsion Engineering Conference exists as a brainchild to solve the problem of having to fling crap out at really high speed off the back end of your ship. And so I think that we can do better, if we understand the concept of fields and forces and have any kind of clue whatsoever about how the universe works at the underlying level, then maybe we can stop throwing things at space to try and move ourselves forward and maybe do something a little smarter.
It seems to me that our physics is based on destruction other than it should be based on creation. Maybe that's what the so-called new physics should be all about. Everything we've done is based on explosion, based on freaking, what's a rocket? It's a controlled explosion within a cylindrical chamber. For God's sake, that's what it is. And if God forbid you miscalculate
it's a ludicrously successful technology.
Opportunities to see exactly how I feel inside, but I won't. Because it's driving
me. Amen to that. Even just the whole, it's kind of crazy. Like everyone here on Earth is like, oh, we need to build rockets to get off of Earth because that's how we're going to save our species. But if we actually could figure out how to live sustainably, then people would be perfectly fine right here. We don't have to if we run into space.
You cannot tell me. Sorry to interrupt, Michael. I promise you have the floor, but I gotta say this before I forget it. Remember, I'm much older than you. I don't know how Jack does it, but awesome, man. At that age, to be able to I think at that age, I'm lucky if I can, anyway, drink a cup of coffee the right way. But okay, I'm not going to go there. I hope I make it. But anyway, look, the bottom line is this. We have to look toward new horizons. We have to look toward methods of creation rather than destruction. That's my cat. I got a cat, one of those things. I think she's hungry, but that's okay. Sorry, baby. She gets a little bit sensitive. But anyway, Michael, you can go back to the whole thing I wanted to say is that our so-called new physics should be based on creation rather than destruction. That's all. Go ahead, Michael. I'm sorry.
Yeah, and all I was saying is, if you think about it, it's kind of absurd that everyone assumes, oh, we have to survive by getting into space, where it would actually probably be much more practical to simply figure out how to live here on Earth with the resources we already have. And I'm working on another project outside APEC, the Technocopia project. It's basically a self-replicating system that takes care of all of a person's basic needs. If you can just make that and have that be relatively innocuous with the waste that it produces and perhaps have some advanced energy generation technology, you could easily, one of the fundamental things on Earth right now is scarcity is used as a means to control people. But if you produce a post-scarcity society, that goes away too. So, yeah, I mean, you would be able to have a world with a lot less coercion and everything. And if everyone's building instead of fighting, that's just a much better world.
To jump on your thought, you don't think that Elon, among his team, I mean, this guy is a multi-billionaire. You don't think among his team of scientists, engineers, whatnot, nobody has talked to him about field propulsion and the possibility thereof?
Certainly, he probably has.
And why? And do you think he's dismissed it out of hand, or is he doing stuff in the black that we don't know about?
Probably the second.
Hopefully.
Well, one would hope.
I just wanted to riff a little bit more on means of destruction's calculation there and the modifier to your equation. So it looks like he was at 0.7 of the Planck force, right? Your thing comes out to roughly about 0.7 of. So for the modifier, if you multiplied it by the golden ratio, it's going to get you kind of closer. But if you multiply it by √2, you're going to get real close. The reason why I'm bringing these particular modifiers up is because you're looking at a scaling force, something that needs to follow the changes in scale. Well, anytime you have something that needs to follow changes in scale, you must invoke fractals, because fractals are the code the universe uses to say, I need something big and make it smaller, take something small and make it big. It uses a fractional dimension scaling relationship there, right? So what I want to say was I wouldn't be surprised if your particular model simply requires a scaling that just so happens to follow some divine freaking number out there, because God made the universe to have some particular code in it, like the Sierpinski triangle or the √2.
Ain't that some? Doesn't that talk to a super intelligence? But anyway, the whole idea of fractals, isn't it awesome that the ability, I mean, we talk about a microscopic geometric pattern repeating at macroscopic levels. I mean, that's what fractals are all about.
Right, like a fractal is both indefinite and finite and infinite within itself, right? It's finite and infinite all within one set. It's a dimension of its own.
As above, so below.
It's
freaking beautiful.
It's worth also,
baby. That's right.
It's also worth noting some of my most recent research. I take some of Ray Stanford, the ufologist from the 20th century. I take some of his data that he recorded, gravitational and magnetic changes associated with movements of the UAPs. And I found some UFOs. I can stand
UFOs.
Sorry.
These are objects. They're physical effing objects. There you go. Unacknowledged effing objects.
1978, he takes all these recordings of it. They do a Fourier transform of it. They find the frequencies that happen to pop out of this. I've done a massive amount of calculations on this, and I am like greater than 90% certain they're utilizing combinations of the golden ratio to induce electromagnetic and gravitational changes, which, if you're dealing with these scaling problems of needing to take your electromagnetic force and fit it down into the gravitational force, you've got to have some kind of scaling correspondence there. It wouldn't be surprising if the golden ratio heterodyning that they're using in UFOs also happens to work with Pais effect.
That's good one, Jared. Good one. Good observation. Definitely. Very interesting, bro. Jeremy, the floor is yours, brother. You can direct it however you want. I'm here for the duration. However, until you guys get bored by me, I'm here. So
I've been told that the secret sauce.
I'm pretty sure that Dave, the physicist, is already bored. He's like, shit, man. Why the hell did I jump on this crap? No, I'm kidding. All right, sorry.
Well, some people say that the secret sauce is really Thousand Island Italian dressing.
Yeah.
But we won't talk about that here.
No.
What do you think about the ideas of you talk about this idea of macroscopic quantum phenomena?
Coherence. Look at slide 8. Look at slide 8 in that AIAA slide paper that I send you. Look carefully look at the wording and look exactly what I'm talking about. What we're trying to do is make sure maximal entropy is never achieved. Once you do that, it's as if you are not allowing the physical system to come to an equilibrium state. Everything in so-called life is based on an equilibrium value. But remember what Kirsten Huang said about equilibrium and about all this dark matter stuff being a out of equilibrium phenomena. You see, read that book. Please read that book carefully. A Superfluid Universe. I bet you maybe 100 people have ever read it, okay? But I guarantee there's some beautiful stuff in there that we can use. That's all I'm gonna say but you'll see what I mean once you start reading, especially toward the end, the dark matter and dark energy part. There's a chapter on it. Read that carefully. Really carefully.
Superfluid.
And have your mind on the Pais effect while you're reading it, and you'll see what I mean. Yeah.
The first superfluid, I think, was what, helium-3 or
wasn't it like liquid helium?
Liquid helium, right? Yeah.
I think so, right? Because that's how Kamerlingh Onus came up. I mean, he got his Nobel but he was doing superfluidity of liquid helium before he found it was superconductive. He got his Nobel for superconductivity, right? Yeah, I think so. And BCS in 1960, they got it for the theory. You know, the whole idea of Cooper pairing. I want to hear your take on Cooper pairing, on Leon Cooper's idea of electron pairing. Do you think it has, Dave the physicist, do you think electron pairing has anything to do with high temperature superconductivity? Or do you think it's something that only
I don't know exactly what's going on. I mean, here the big problem is trying to figure out what is the mass of the Cooper pair. I know that's a big mystery with it. So yeah, I mean, I feel like we just don't really understand exactly what the true theory of superconductivity is. Yeah, I'm not a condensed matter guy, so I don't have strong opinions on what it should be. But it does seem that there's something to figure out there. Maybe is gravity related or not to figure out that mass difference? I'm not sure. I don't know. So say too much.
That's a good point. That's something to be looked at. Jeremiah, did you read the Victor Lachno? I know Michael Perrone has read it. Have you read the Victor Lachno paper on high temperature superconductivity?
I haven't.
The mechanism that yeah, go ahead.
Not yet. I haven't read the paper on it yet, but I do have an operational sort of intuition about Cooper pairing and room temperature interaction.
Look at the last page. What he says. He says Pais may use an alternating magnetic field, right?
Well, if I could suggest something too, interesting
to disrupt the surface superconducting layer, hence creating a Bose-Einstein condensate. And then he uses what? An alternating current. I can almost hear Dollard's right here at the back of my mind. Alternating current to do what? To cause dynamics of the Bose condensate.
Right. If we get two electrons, right, and we get them to phase synchronize or couple, quantum entangle, what's going to happen is the two spins are going to oppose each other in terms of producing an interactive magnetic field as it's flowing through the conductor. So even at room temperatures, this randomized conductor, which would normally be...
Slow down, please, for me.
Sorry. Okay. So so at cold temperatures, when you have an electron flowing through, its electric field is going to follow its attraction to all the unpaired spins or any kind of imbalanced charges surrounding the nucleons and the electron clouds, right? So it's gonna be predominantly following a pretty linear path, and once it cuts through, it's gonna spin polarize the surrounding electron valences through their interaction with the nucleons to create a pathway where it can now tunnel. So once you get one electron to do it, then the next ones can do it very easily, and so they'll link closer to each other and spin polarized. But
so it becomes like a giant matter wave. It becomes
a matter wave, right?
That's where the coherence comes in.
But here's the room temperature part. So this is where it gets interesting.
Right.
You don't have to have super cold materials in order to get this phenomenon to occur.
As long as that piezoelectric material, right? PZT, lead, zirconate, titanate, all of them, lead, zirconia, and they're all what? Low temperature superconductors. So you need them. You need them to be superconductive at low temperatures. And then you bring the TC up. by this mechanism. I'm amazed that this this guy's Russian Academy of Sciences. How much you want to bet there are a lot of scientists out there, okay, in certain states that I won't name. There's no need for this to be taken down later. So that are looking at this stuff very carefully, if they don't already have it.
They should be.
So basically, it's a 4-ket superconductor, right? So it's a driven coherent state, and it's a Bose-Einstein condensate state, and you're using bipolarions instead of
that's exactly what Lachmann was talking
pairing.
About. Bipolarion mechanism. It's not it's not the Cooper pairing, correct?
Yeah, it's
right.
like
or not the traditional Cooper pairing, at least. I'm sure you still have bosons.
No.
It's like a short horizon entanglement. Yeah. So
it's
that's
definitely in one. So Cooper pairing somehow still links to it. It's just another level of it. But yeah, then Leon Cooper,
of it.
What an idea! I mean, who'd have thought? I mean, think about it. The electrons overcoming their Coulomb repulsion to pair up, do a dance together. That's effing brilliant.
Phenomenal. Yeah, exactly. And they naturally do this when you get them to interact at just the right angle, and they have an almost equivalent velocity. If they cross
a mind like that, we need in that MMA cage, and we don't let them out until we convince them, one way or another. Combat of the mind, baby.
Seen it. Okay, we've already seen this
combat of the mind.
So to prove the point that you can have room temperature like superconducting states, we've already seen it in boron and in carbon nanolayers. And just by changing the interaction angle of two different lattice grids, we can now create these magnetic moments which allow that interaction to occur. The interaction is rare, but if we can get two electrons that are traveling across at some angle to each other to actually link up and get their spin states completely crossed so that they entangle just for that moment, it's like a short information horizon synchronization. It's not technically superconductivity. You have still two independent electrons, but they are spin synchronized, so they're more, their interaction with each other is stronger than it is with the rest of the lattice. Hence, they experience no resistance.
Given that physics, how would you explain the Meissner effect, though? Given what you just described, how would that particular structure you're describing make sure that no external magnetic field? I mean, it still penetrates up to the London penetration depth. It still does. Everybody talks as if it's total expulsion. No, it still penetrates. But we're talking about microns, right, Michael? We talk about microns. We're not talking about freaking So
it goes from having a wave equation solution to a what was it? Laplace? No, that's not. That might be. Well, it's got exponential solutions. It's got evanescent solutions, I should say. Not.
Which brother came up with that? Was it Fritz or Heinz? It was one of them. There were two London brothers. You know that, right? There were two London brothers. Yeah, both of them really high up. But anyway, yeah, it's pretty cool how they were able to show quantum macroscopic quantum phenomena, that superconductive, right? That's pretty cool.
It's amazing how far apart you can get two electrons and have them still stay quantum locked with each other. It's shocking. Once they get locked into that state, they seem to be interacting almost at superluminal velocities.
That's weird, though. Why 3? Why not 4 or 5? Why the number 3?
That's a good question.
Dude, man, listen to me. Tesla did not believe in the number 3. Remember what he said about 6, 3, and 9? And all those numbers are divisible by 3. So again, 3 at the basis. Tesla did not believe in the number 3 for nothing. But I wonder if he ever wrote it down. His philosophy of the number 3. It's powerful as hell. I mean, look at the other dude. What's his name? The one with the Pauli exclusion principle. He was crazy about understanding the fine structure constant. You know what I'm saying? There's a philosophy to these numbers, man. Look carefully at 1 divided by 137. Put it in a calculator. You'll see what? 0.007299, and then the thing like repeats the other way. It's like a freaking vibration, almost like an arithmetical vibration of sorts.
Well, any
Put it in your calculator. 1 divided by 137. You see what I'm talking about?
Any rational number will do that, though.
One reason why he might have been all up into the 369 numerology, though, could also be, I'm throwing this out there, the universe as an information computational machine happens to run on a ternary-based system.
There you go.
Well, I mean, if you think of particle collisions, technically you can only have vertices with 3 edges connecting to them, I think.
Yeah, Feynman thought this was a magical number too. Yeah.
And there's 3 Whittaker potentials, even though it was claimed that one was unphysical.
Yep.
Yeah, there's something very interesting.
Man, I love that.
What do you guys think about Frank Wilczek? The whole idea that the materiality of the quantum vacuum. Ain't that? I mean, the guy. Did you ever see him go against Lawrence Krauss? You know, everything came from nothing, something like that. Did you ever see?
I think I might still have to watch that one.
It is heavy, bro. You gotta watch it.
He said we're children of the ether at one point.
One of the best. Yeah,
that was
amazing.
I mean, this is the inventor of time crystals, but dude, listen to me. Wilczek has a mind like, I think, in my opinion, he's the best we've got right now. And I'm sorry, Nima Khani Ahmed, I always thought you were great, but since you never answered my emails, I'm kidding.
Better than Ed Whitten.
Anyway, that's funny. Anyway.
You're more scared of Wilczek than Ed Whitten?
Oh my goodness. I think Whitten would give me a headache. I mean, he is the most mathematical person in the history of physics, in my opinion. Even, did you see what Eric Weinstein has to say about Frank? I mean, not Frank, but that. I don't know. I regard Wilczek as the greatest, but that's me. You know, what's the name?
Trying to get Eric
Weinstein. What he says about, yeah, Weinstein is pissed at Whitten for supposedly, and Dave the physicist know what I'm talking about, for slowing down the advent of physics with string theory. Really?
Yeah, but I mean, he's just trying his best. I mean, at the end of the day, everyone's just trying.
I remember who his father was, Louis Whitten. Hey, right there, Jeremy. You've done the research. You know who Louis Whitten was.
Yeah, they were the father-son team for Martin Marietta.
One of those quote-unquote guys that kind of in the 50s just kind of like, whoo, what happened? Remember, you know the names. Was it the Bobson or remember the quantum
Bonson Labs and
Kurt Mongol has a thing on his theories of everything with this, with the
Bonson, the history
with quantum gravity, the mystery of quantum. Yeah, very interesting.
Very
really interesting
story. They put tons of money into this.
Top physicists, okay, work on this. I mean, for God's sake, we talk about DeWitt. We talk about the Wheeler-DeWitt equation. We talk about Wheeler. I mean, this is John Archibald. You know, matter tells space-time how to curve, and how is it? And space-time. How does it go? And space-time tells matter how to move. Something. I would replace the word matter with energy density, and I would do something anyway with fluctuation. Sure. I think it's in one of my slides, but that's the only thing that I would ever change on that was beautiful.
Well, that non-Riemannian geometry that Eric is interested in is also in string theory, but most string theorists don't even realize that either. So
yeah, good point.
It's they're not as far away as it seems. In fact, it turns out that Eric Weinstein was actually influential to finding a solution to the origin of M theory, but I don't think either Eric or Ed Whitten are aware of that in detail. So I don't know.
Really? You should reach out to Weinstein and let him know.
Yeah, I've talked to him a couple times.
I mean, for God's sake, the way remember that crazy paper that they tried to publish on Archive with this guy? He wouldn't even give his real name. Called himself Theopolia.
Oh, like,
the god of everything. It was just some weird translation. And dude, what's up with these people, man? I mean,
he's a real person. I talked to him.
Now the other guy, Timothy Noon, he is a really good physicist. I've seen certain things. I mean, you know what I'm saying. But give Weinstein a chance to respond. Don't attack him in that manner. You just don't do that. You know what I'm saying?
Too, you mentioned this guy with a name. People have said like, "Oh, Salvatore Pais translates to "savior of our nation," and that's not
my God,
name.
Yeah. Thank goodness they don't remember my middle name, because my middle name is Cesar, in the Romanian for Caesar. That's all I need, you know?
Yeah.
Forget about. Look, I do believe that a name is everything. In Latin, it would be like "patum meum nomen est." My name is my destiny. But you know, that would push the degree of hubris so high that these people would explode just by reading. Hey, maybe that's not a bad idea. Anyway, again, let's try to use creation, not destruction. So, anyway, yeah.
There's only one name, the Sarfati.
The Sarfati, dude. I like him. I tell you, I really like the guy, but the way he attacked, especially the craft using an inertial.
It's hilarious.
Oh my God, when he got I mean, come on, man. I was already in the doldrums, you know. He freaking, you know. Anyway, thank goodness that that's
his approach to everything. So it's like it's hard for other people too, because it's like, well, there could be other legit theories.
Bro, he's a nice guy. I know deep down that dude is not a nice guy. I just have this
feeling. Seems he's old, and it's just like he's on his one path, and if it's not super relevant to his path, he's just like, forget about it, or just done with the schmucks, right? So it's like that's super relevant.
But you're right. You're right. It depends on how he says schmuck. I've heard him say schmuck in a nice way, and I bet you he didn't mean that. So yeah. Sarfati is someone that can be dealt with. And I think so can Eric W. Davis. I'll never understand why EWD, dude, the way he attacked my work. That's why the Senate Armed Services Committee basically stopped completely. They were gonna do all kind of stuff that I can talk about because stuff. But anyway, he just reached out, said this is complete garbage, complete bullshit. Boom, gone. And he reached out to one of the most influential people out there. And you know who you are. His initials are JS. I'll stop there because we talk about O and I and above. Yeah, another 3-letter wonder. But anyway, I almost started working for them. That's a different thing in a different lifetime. Maybe in a parallel reality, I'm already the director. By the way, hey, what do you guys think of this Arrow office? What's your take on it? I really want to hear.
Seems like a bureaucratic thing.
Sorry. The idea that looking for anomalies, that we have to resolve aerial anomalies, it's just not the right approach to the science. I think we need to be looking more at the trillions of dollars in unaccounted for black budget programs in this country. We have stovepiped operations that potentially have the capability to hide the existence of aliens and alien technology, according to some of these whistleblowers and people that have come out in front of Congress. And I believe that they have the capacity and the capability to keep secrets of that magnitude. And that's something that shouldn't exist. So I don't understand why we need, why we're looking in the sky to try to resolve aerial anomalies, when the real problem, it seems like, is, well, where are these technologies, and how do we make sure that the American people get this access to this technology before Trump or a Biden can go and outsource and sell the secret documents to China or Russia or something? That's what I'm worried about, is how do we get this in the hands of people like
individuals that can make progress, real progress, not the bullshit they call progress.
Can I also answer to the question about Arrow? So we've dumped a huge amount of money into an observation program, and I think the big question we have to ask ourselves is, what has the Arrow program done to benefit the research efforts,
the physics,
the scientific community, or even the military research, right?
You guys have done more at APAC, putting certain ideas forward than, ain't that some?
Right. It's
And
like you gave them lots, and what are you getting for it, right? What are you getting for it?
What's their funding?
It's a political thing. Yeah, Arrow is a political tool, basically.
Yeah, our money disappears into the program and nothing comes out of it. That's the real problem. And so it's sort of just like a financial black hole at this point.
No,
I'm not sure that we need it anymore.
It manufactures a narrative. That's what it does. I mean, it's not very actionable on the ground.
And you know another thing
Science
that bothers
should
the
never
hell out of
have
me? This reverse engineering technology is to say that the human species is not, how should I say, imaginative, creative enough to come up with these ideas. As I've shown, and actually the Pais comes out of 1890s physics. You think what Walter Bosley and Dr. James Joseph Farrell was talking about with the Sonora Air Club, NIMSA, and all these weird airships that use very interesting technology. You are telling me that we must depend on ET technology to progress? That's like a slap in our faces. We should be very
stupid to figure this out, right? There's no way. You had to have copied it from aliens. Come on.
Well, I am 100% sure we can do it. That's what I'll say. Absolutely. As a human species,
I'm with you, Jeremiah.
We might be monkeys banging rocks together, but I'm sure we can do it.
In his soul of souls, believes the same thing. And I know Dave, the physicist,
you can feel it.
But he has the math to prove it.
Yeah.
So
you know when you've seen these weird anomalies and they just, even if you've only seen them ever once, like something opens up in your mind and you're like, oh, wow. Turns out that impossible thing actually does happen. And so for the rest of your life, you may see something once and try to talk to all the physicists and all the professors in the world, and they'll all tell you that's impossible, it can't happen. Look at the mathematics.
Boom.
Here's
10
there
are no impossibilities. There are no impossibilities, just conditional possibilities.
Exactly.
Everything and all is possible under certain conditions. The trick is to know how to engineer those conditions. That's where you young minds, you people of the future, okay? Because I've eaten my bread. Who knows what my end will be? But anyway, you guys are the future. Take it toward the next step. Don't depend on anyone else. That's the bottom line.
Yeah.
Do it, brothers. But be careful how you talk about the results.
Right. Well, I mean, to all the naysayers that want to stay locked into an old paradigm.
We are not here to enlighten and educate the enemy.
Right.
EQ. We are not here to enlighten and educate the enemy. So be careful. That's all I'm saying.
Can you say anything about who this enemy is specifically, or?
Yeah, I was wondering that too. Is it
you're
ally?
No, listen, we are all Americans. We are all United States. Dude, I love this country.
And Canadians, but luckily allied countries, Canadians and Americans, all allies.
There you go. All right. I don't know what to call us, but you know who I'm talking about when I say no, I'm not talking about the 3-letter. You think they're part of us, man. Okay, that's the.
But what about enemies within, though? Like you mentioned,
dude, I'm not
like
talking
Jeremy
about.
Mentioned.
What?
Yeah, well,
like Jeremy mentioned, the enemies within, like the people like the Bidens and corrupt.
Unification. The problem that we're facing now is because we're so freaking polarized. Oh, I like this. I like that. Deep down, we should unify. That's the only way we're gonna survive what's coming, brothers. There's so many, and you know what I'm talking about, that have us in the crosshairs ready to pounce because we're filled with natural resources. We're at a perfect position. This is an island, but you think it cannot be invaded? Think again.
There are no enemies here. Just Earth.
Again, there are no impossibilities.
Not here.
We must unify and work as one super force. That's the bottom line. Yeah, why not?
Yes.
This is
how do people join Superforce?
I'm apolitical, but from this point of view, I am political.
I love that.
Unification. Unless we come together, we shall fall apart. Period.
I agree with that.
FDR knew that, but was it worth it after the war? Well,
it's the only way, brothers. It's the only way. We put our differences aside and come together. Otherwise, we will not survive as a nation. You would not believe what's out there. And it's not.
Do you believe that we should have our government should be having like a Manhattan Project 2.0 to develop this technology?
If they don't have it already, they should be generating the next tele-ulam device. Need I say more? You know what I'm saying? Something that whoever it is has to come at the negotiation table. It'll bring on a new epoch of deterrence. You tell them such and such a device, if it does exist, it'll snuff you out of. So, your choice, because no sane nation is suicidal, and insane nations should not exist. Period. Okay, I've said my thing. Jeremy.
Problem is, if you have an insane nation and these weapons.
I'm pretty sure they're going to kick my ass for this, but F it. I got to say my mind. Otherwise, I feel like the slave.
Hey,
anyway.
Well, if you get fired, we might be hiring. So,
hey, there you go, brothers. And then, no, but trust me, they would take me out of commission before. Anyway, I'm not going to go there. I hope.
I don't see how if you have an insane nation or a one.
I hope our guys, the good guys, understand my worth and you guys' worth, and have a good place for us rather than, because oh my goodness, if that's not the case,
here's hoping.
But if it's true that we do come back, F it, I come back, and this time I'm a supermodel. Nah, anyway.
Hey, Sal, so jokes aside, though, if we happen to be able to get funding to be able to put together the dream team, and be able to realize some of your ideas, I got two questions on that. One, would the heme fig be your go-to experiment, or would it be a different one?
Nah.
And two, would you be willing?
The superconductor would be the first I would try. But
and would you be willing?
Too. But the room temp, see, that's the thing, man. As far as I'm concerned, I work for the good guys. So until my boss comes to me and say, you know what, there's a skiff for you or whatever, a laboratory in a skiff. Ain't that something? That would have to be a big skiff, what I have in mind. But anyway, here it is. Assemble a team. If you guys get a call, don't look surprised. But I am saying, what I need, we need people that do away with the box, brothers. F the box. I'm sick and tired of hearing, thinking outside the box. That's not good enough. You do away with the box. You start something totally different, a new physics based on creation rather than destruction. The whole idea of a super force, not just physically, but
instead of a box, a vortex, for instance, like a different geometry to begin with.
Vortex dynamics. We got to go back to the physics of vortex dynamics. That was too easily snuffed out of existence by certain mathematical progenies. Enough. Let's go back to real physics, bros. Enough mathematics.
So
do some physics.
More mathematics. Yes.
So a private sector skiff is still out of the question.
Only if it's backed up by government, like some sort of Prada or something of that nature, where I could be the government rep. But man, look, the truth of it, I really, in my hearts of hearts, you want to hear what I really, I do.
I want to hear exactly what you have to say.
There was a time that I hear, as long as some footnote over there has down the line, it doesn't even have to be within the next 10 years, but down the line, this crackpot was not a crackpot, and he was actually correct, blah, blah. That's all I care about. What I care about is that this stuff, and I'm praying that this stuff is already out there in some freaking vault, because I've read a lot of books, military tactics, strategy, history. I do more than just physics. I like to dabble in many things. Call me, again, a jack of all trades, master of none. Fine. But my instinct tells me that what's coming is surreally bad. So I'm really hoping that in some bowl somewhere, this physics already exists and we're ready to put it out and basically slap the enemy around a little bit, just a little bit, and then slap him some more to make sure he never does it again. That's my hope, that this stuff already exists. Because if it doesn't, brothers, you guys better work really fast, because we don't have much time.
There's been plenty of higher level folks who have hinted at the actual existence of what you're talking about. And they've even hinted at it during superpower versus superpower talks, like, hey, we have weapons that you can't possibly fathom. So, you know, nukes are off the table, obviously, because we got something even better.
Hallelujah, man. I hope it's true. I hope it's true. I get so, again, my daughter keeps saying, you know, Daddy, you got to be so a little more positive. And I don't see it. My instinct tells me we're about to hit the abyss of cesspool time.
What did Einstein say?
I hope I am.
Empires rise and fall, but I mean,
sorry,
you gotta. When things change, you just gotta take care of the people around you. At the end of the day.
Right. Yes, but again, we have, look, man, unification. Do away with this polarized stuff. So what if such and such has this belief and you have this belief, and I disagree with something Jack Sarfati said or Eric W. David? We're all American. We all want this land to progress. We have to come together. Put aside our differences. We have enemies out there that would, in a second, not even a second thought, that's the hatred that can be weaponized against us. If we don't unify, it's over. There won't be a United States 5 years from now.
SDI,
my instinct tells me will happen. I hope I'm totally wrong.
The Cold War did not end because SDI was a failure. The Cold War ended because the SDI program was a success.
Again, physics of creation, not of destruction. But first, we have to win a certain
competition,
combat of sorts. It's far above. I'm so sick and tired of your peer competitor, adversary, whatever. The other one, near peer. What's up with this terminology, man? What's happened to the good old Karl von Clausewitz Total War enemy? Because that's what we're talking about. If you're around the bush and treat them like they're freaking cream puff, then you're gonna fight it like a cream puff.
As Liminal has said many times, and she's known
these are effing black bears that are coming toward you.
Oh,
and all you got is a toothpick. What you gonna do?
Liminal has said that
actually, I saw a black bear in the forest once, and it was definitely thinking about attacking me. So I took out a San Pellegrino bottle and blew on it, and it didn't know what the heck was happening, and it ran away.
Sounds they don't understand. Yeah. You can, yes, most definitely. See, again, asymmetric. I love it. The way you think. Again, new methodologies. It hasn't all been tried. Yeah. And remember one thing, they forget that Americans are very effing creative. So come at us, mother. Okay? Come at us. And you'll see some surreal. I'm still hoping somewhere in the vault we have the secret source. You know, I'm still praying for that, because it would make things so much simpler. You know, a certain switch is down.
Are the Tic Tacs potentially American AI technology, or do you believe they're off-world?
If you look closely at the narrative, especially with the Air Force personnel coming, you kidding me? Have you ever been on board of a carrier? Have you ever been on board of? Oh, dude, man!
I'm a poor Canadian. We don't have them, sadly.
The idea of someone from another armed service coming to your vessel and basically commandeering you around, dude, man. The captain of a vessel is God on that ship. So the idea that these people had the power to remove all these drives and stuff, that basically says unacknowledged effing object. Thank God. So yeah, I'm praying. but I have a feeling. I mean, come on, man. Look at the four protrude. I mean, come on. Those are, if you know,
again, the U should be changed from unidentified to unacknowledged.
Unacknowledged effing objects, all right? Jeremiah, and you know what I'm talking about. Remember those protrusions, those wedges? You know what that speaks to. I mean, how would you communicate with an object of that nature? Especially if it does what it does. It would need something very special.
Oh, yes.
You know why I'm
use
going.
those little fluctuations in the refractive index to talk to it.
Anyway, so what I'm praying for again, that somewhere in the boat has the secret sauce. And this way we don't have to go through the, you know, through the misery that war creates. Because total war, brothers, I mean, holy. Anyway, you know what I'm talking about. Yeah.
And especially once you have the bomb, that's a whole different level of war than anything we've
Again,
seen.
when you have something of that nature, you don't even need to fight a war. That's basically winning a war before war is fought. You come to the negotiation table. They bring their best physicists. You bring your best physicist. Oh, talk about weaponizing physics. I mean, the physicist being weaponized. You bring them, you say, this is what I've got. Their physicist takes a look. You see all of a sudden droplets of sweat coming from the eyeballs, coming from the nose, coming from the forehead. He looks over at the military commander that he came with, he said, and he says something in that specific language. The military commander salutes, walks out, and all of a sudden you see the political representative coming in and say, we're now friends. Why? Because you don't have a choice. That's the kind of thing. That's what we need. That's why we need something that can solve this at the negotiation table before one woman, one child, anything is snuffed out of existence. Now that is what I would call great physics. Something on the order of the Teller Ulam device, you know, something that.
This reminds me of the whole. I don't know if you've seen Oppenheimer, the movie, but this is like the whole debate in that of like, do we use it to? This will actually save lives if we use it in the timely fashion, and the arguments that they had to go.
It's a new epoch of deterrence. Again, remember what I said. No sane nation is suicidal, and an insane nation must not exist.
However, if an insane nation does exist and you do have these weapons, how do you deal with that then?
You're a smart dude. I know you know the answer.
Yeah, it's not pretty, but hey, I guess not all things are. My favorite part of the Oppenheimer movie, though, is
you tried to be human. That's all we can do is try to be human.
Remember when they
and if the response is inhuman, how do you deal with it? Do you just cower back? Do you put your tail between your legs and run home to mama? What if mama's not there?
There's an episode of Stargate you should watch, The Nox.
Sometimes you gotta play the trump card. Anyway, oh my goodness.
I'm somewhere halfway between that perspective and the other, because there's two extremes. Either you go in with a knockout punch, instantaneous success, or you change the dynamics of the power structure so that there's no longer any motivation.
Can I explain how they did it? Let's explain how they did it in Oppenheimer, because Oppenheimer, they had all the physicists writing out all the equations on the board, and then they went through the math and they said, this is impossible. It can't be done. And then the guy came in the room and said, hey, they're doing it next door. And that is where the moment where the physicists in the theoretic room were like, oh, well, maybe we made a mistake here. There's something wrong, because Fermi and his counterparts, Enrico Fermi, were doing it.
Man, Fermi have.
So it's
those guys, man. The Hans Bethe, Hans Bethe was Sarfati's mentor, wasn't he? Who was Sarfati's mentor?
So he claims.
No. Trust me. That dude. One thing about Dr. Salvatore, he knows he knows his stuff inside out. I take my hat off to him. I just wish he didn't call me an idiot to my, anyway. So, but what I'm saying
it's an honor to be called a schmuck or an idiot by Sarfati.
Yeah, really? Damn.
Only when he's smiling. Only when he's smiling. What it means is
smiling schmuck list.
I can translate the smiling schmuck, okay, and what it means is you're onto something, and I'm glad I'm going to figure out the math before you.
They're our guys, so okay? That's the bottom line. They're all good guys. Jeremiah, they're all good guys. They're our guys. These guys, okay, we would, trust me, if the enemy all of a sudden showed up, how much you want to bet we'd all put our differences aside, solve the problem, and then once it's done, we'd come back to ourselves, and Dave would tell me, your math sucks. I said, yeah. Remember how I said when that guy came in, and he'd be like, okay, maybe I'll write a paper with you and show you how it should be done. There you go. So what I'm saying is, the bottom line, we come together.
Right. Let the engineers build things. Let the mathematicians figure out the equations. Let the physicists theorize about how all these things intersect together. And everybody do what they do best. But let's not be at each other's throats, because an engineer only with no mathematical aptitude whatsoever, but the ability to fix anything by practically looking at it, and the guy who can think in numbers when he dreams but couldn't build a thing to save his life, when they work together, right, what happens? We have this unity all of a sudden of a full explanation plus a physical apparatus that's experimentally verifiable in the lab. And it is in the unification between...
I must agree, experiment trumps theory every time. I 100% agree. But remember what Dirac said about experiment. He said sometimes the beauty of the mathematics should precede. Because one thing about experiment, you got to be careful with experiment. It has to be under certain correct condition. Sometimes people, for example, let me bring a very interesting experiment that's always intrigued me completely. The Hayasaka Takeuchi experiment. Remember the rotor that all of a sudden lost weight? It always intrigued me. Those dudes got published in Physical Review letters. It was a December issue. I still remember. So maybe the guy was trying to get home to mama, because she cooked really good food or something, and just passed the paper. That's possible too. But I don't think so. I think something in that paper spoke to the editor that said, okay, we'll pass this. All right. This is Physical Review letters. This ain't, Mojo's excursion into physics. We talk about the greatest of publications. Look carefully at that experiment. There's something they did, and I think it has something to do with cold plasma. Look what I say in my paper on the hybrid aerospace undersea craft, that AIAA space paper from 2017. I have some brief stuff on Hayasaka Takeuchi. And it speaks to some lecture notes from Kip Thorne. Ain't that interesting? Kip Thorne. He's a gravitational guy, huh? But going back, okay, now I'm jumping from here to here, but I'm trying to connect the dots. Sometimes you got to jump. Anyway, remember the 1950s, all these great physicists? We talk about Lewis Witten, Edward Witten. I remember him saying the one true giant that he thought was much better than him was his father. So we talk about one of the greats that ever lived. We're talking about the DeWitts. We're talking about Wheeler. We're talking about who knows who else. Feynman for sure, because if Wheeler was involved, so was Feynman. But anyway, so, and all of a sudden this thing goes dark. You see what I mean? Too many things that don't make sense. Hayasaka Takeuchi, within 1 or 2 months, 3 or 4 papers, 2 of them, I think, in Physical Review, another one in another great journal publication came out. Null results. then two more within a matter of 6 months. So almost like 5 or 6 papers within 6 months.
Sounds like what happened to Scheuer. You know, Robert Scheuer went through the same thing. First it worked, NASA's talking about, hey, success, and then it was all null results. Oh, test measurement error, right? So, I mean, it could be.
You know one guy that scares me, that at night I'm like, I wonder where he is. I wonder how much money he has, what kind of teams he's with him. In Russian, his name is Evgeny Podklenov. Remember him? Eugene? That's the name of my uncle. So I have great admiration for that name. That my uncle meant a lot to me.
I've deeply studied his
gravity
impulse beam. Deeply studied it. I mean, I would love to talk with you about the physics of that at some point. It might be something off the air.
You know, that interview with Podkletnov wouldn't exist if I didn't put it on the internet.
Yeah, dude, your stuff is epic, and it has been.
Worked with Evgeny, especially Dr. Ning Li.
And she was the one that actually developed those special superconducting materials. She was the, she was the dragon of the West, in a manner of speaking, the real brains behind the material science.
That's why I hold Jeremy in such great admiration. His research, bro, the way he's been piecing these things together. You see what I'm saying? And I tell you, brother, you have some high-level enemies, bro. That's all I gotta say.
Yeah.
I'm pretty sure, so do I. But look, they say that the quality of a person is recognized by the status of his enemies. So if we didn't, that means we're not worth anything. So cheers, my brother.
Sal, you were mentioning...
This is water, by the way. For your information, this is water. YouTube, this is just water.
Sal, you were talking about...
I'm kidding. Go ahead.
You were mentioning about patents going dark, and I just talked to an inventor here just a week or two ago who has submitted multiple patents that they all end up going dark. There's something like 8,000 or 10,000 different dark patents. Your patents had the special aspect of them that they went before multiple Navy review boards and high-level review boards, and yet they still didn't end up going dark. Why do you think?
Even after the Senate Armed Service Committee sent an all-day team to investigate, they still didn't go dark.
Do you have any ideas why they didn't?
Between you and I'm so glad, because I want the enemy to think this is disinformation. Even though I say that I want to be vindicated deep down, man. Look, if it's between us winning the war and me being that effing crackpot, I choose winning the war every freaking day. Because I'm American at heart.
Ending all war permanently across the planet. That would be goal.
It's our made in Romania apple pie, American pie.
American apple pie made in Romania, baby. I'm very proud of my land of origin. I'm very glad that Romania is where it is. So, anyway, so very proud of being American and very proud of being Romanian. So there you go.
Can I follow up on that? Have you submitted any patents that did end up getting taken and had to go dark?
Again, I quote on Ashton Forbes, I said, I will not lie, because layers upon layers upon layers of lies masquerading as truths should not pass go. So I will not lie. No such thing. As a matter of fact, I think they were very happy with me not doing anything else after those 5 things went through. Because I think I'm the only one that was able in front of, these are, dude, look up NAVID technical fellows. These are no mental midgets. These are no cerebral troglodytes. These are the real deal. If they pass muster, every one last of them, that should tell you something right off the bat. Actually, when I was given the talks, and we had multiple meetings, that's what keeps me going. Remembering the faces of these ladies and gentlemen in the room and certain flag officers. Thank God we have these people around, bro, because that's how we're going to survive what's coming. They exist. Thank God for them. And that's what I'm saying. The one weapon that they do not understand, and it's fueled by the way we were brought up, is American creativity. And I really, really pity the enemy that goes against us, because that will live on forever, bros. And even if we take a beating, because sometimes you lose the battle, we shall win the war. And that's a prophecy.
Amazing.
I know the last prophet and stuff, but
I think we're at 3.5 hours, Sal. This is a record for you. You want to go to 4, man? I'm down. But I think your cat is like.
Are you kidding? Holy shit! Oh, sorry. Maybe
24 minutes. I think we should make it go to 4 hours, and then I think we got to have Sal back for another episode and have Sal on APEC.
Yeah.
Sal deserves an APEC as well.
Now we're not talking. Okay, let's not talk physics. Let's talk, for example, what would you do with this? Oh, fine. What would you do if you were to come up with these physical ideas? What would you do to advance American science toward keeping our superpower status forever? What would you do?
That's a tough question. I would recognize how do you get it to not turn tyrannical if there's only ever one power?
May I? I actually have an answer to that question, Sal.
Remember what we are. What is the American democracy? It's truly a republic. But we elect the people that represent us. Therefore, it's at the bottom, the people are the leader. This is the beauty of this country. No freaking oligarch is going to make a call and make you.
Well, unless you have manufactured consent. Civics is no longer a class in school.
We're still
it should be.
But anyway, what would you do to advance civilization? Not just American, but civilization. How would we break the bounds of Earth and become an intergalactic civilization?
We would have to first solve the major problem of scarcity.
Post-scarcity is more important. Post-scarcity is more important than getting to space right now. If we go to space right now and we don't have a post-scarcity civilization, we'll just bring all our problems with us. We'll be able to escape the gravity well of the Earth, but we won't be able to escape human nature.
We'll be doing what the Indian Independence Day.
So rockets are definitely not the solution. Agreed?
Well, neither is anti-gravity.
I completely agree. Rockets cannot be the solution.
Maybe as an initial phase, fine. But it should be a bridge, and more money should be put, or more funding should be put toward the advanced technologies. You cannot tell me that the only way to move a craft with space-time is to throw that freaking fecal matter outside the nozzle. No, I refuse to believe that.
Yeah, if we can't clean up Earth, then we're just going to make a mess in space.
Oh.
Yeah, post-scarcity is should be the first.
You might
objective.
not like this,
and
Dave,
people think it's harder.
but there's a philosopher inside of you, Dave, the philosopher physicist. Nice, very nicely put. No, for real, very, very nicely put. Very nicely put. So, good.
Yeah, we have to figure out post-scarcity first. That's at the end of the day. That's the key thing. If we're going to have all these godlike technologies, we better have the wisdom too.
Yeah.
I think transportation is key. It's not to get out of the scarcity. It's not that just that we have enough stuff. We need to be able to transport the stuff. I think that's kind of the biggest
problem. So maybe we should crack, if not room temperature superconductivity, highly efficient and cost-effective high temperature superconductivity. So maybe there's an interim step between the holy grail of condensed matter physics and what we can just to advance the state of civilization. Sometimes you take baby steps, but you still advance in the end, incremental.
I met a man once who came from the future, and he said self-replicating factories. That's a bit of a claim, but yeah.
Self-replicating factories, like
kind of like AI
like
does.
Neumann probe,
become like the nucleus of the cell. We have all this equipment that, you know, yeah, we're the brain of the cell or the brain of the household equivalent, you know.
That dude that came from the future, couldn't he give you the time excursion, the temporal excursion technology? Because that would solve
this
a
was
lot.
More important. This was more important.
Wow.
Because our society is analogous to a slime mold. Each individual unit needs to be self-sufficient, and the whole structure then becomes self-sufficient if we cooperate properly. But right now, the individual units are not self-sufficient, so the system is brittle and subject to many failure modes.
It's deep.
That is accurate.
What do you think, Jeremiah?
I think the analogy to a slime mold, or more closely, mycelium, because we do actually share a lot of genetic structure with mushrooms, the way that they cooperate and collaborate with other structures around them. For example, many will feed nutrients to tree roots while taking away some of the garbage products that they generate and transport them through the entire network. So yeah, the solution ultimately is, I think we solve scarcity by unifying our resources and the brightest people in our societies, instead of trying to say, you know, I did it first. It's more about we did it together.
Do you think we'll ever be able to come together as a united Earth?
I think that APEC is a proof of that. I think that APEC proves that people from all across the world, because we've had people on from so many different countries, and they all came together because we all believe in this one concept that, hey, if we can solve this propulsion problem with alternatives that aren't rockets, then we just might be able to solve the scarcity issues as well, because we can get resources to and from where they need to go at a cost that is far less than the cost of actually obtaining those resources. So behind that, the fact that it came together, and it came together very smoothly, by the way, it was almost no effort. Tim stepped right in, took over mod. Mark and I had no problem bringing just about everybody you could imagine in. I mean, Mark kind of just took the whole list and sent everybody emails at once.
When people have a common objective that is worthwhile, that talks to advancement of all instead of just individuals, you're right. This can be achieved.
I believe in it, you know, because it worked before, because we've seen it. I know that we can actually come together.
That's how I'm able to sleep at night, because I believe one day we will be a united Earth. And guess what? Even then, there shall be an external enemy. What's up with this almost dichotomy between good and evil? It's like for everything that's good, there must be a counteragent.
It's subjective and created by our psyche. You can fight against it. But anyway.
Right. The ego is always going to be in competition with the idea of unity. And some people are going to be controlled by the ego, and they're going to think, power for me, and some people are going to be aware enough to recognize the power of unity and realize more for you, more for me.
How do we deal with re-engineering human nature? Do you think that's possible? To make us act
more flexible.
Turn off the television and turn on AlienScientist. That's how.
Children are the future.
Lead by example. That's how.
Have you ever seen ants, how they cooperate? I mean, ants, they can be individual. You sometimes see an ant going away, you know, doing his own thing. But then when they act together, the stuff they can do, they can freaking, a field of ants can carry a freaking dead fox away. Why not?
Be the change you wish to see in the world. You know, Gandhi.
Yeah.
Once we have multiple
that's why we're all here right now, is for that goal and working together and open sourcing it and putting it out there.
See, but the fact that we have to watch every other word we say and be extremely careful not to educate and enlighten the enemy. Why must there be an enemy? Why can't we just come together as one united Earth? I know it sounds almost like, you know,
society's
holding hands and singing Kumbaya, but I mean this seriously. Why can't we just be unified as a global entity?
That'll take a couple thousand years more.
No. If you have multiple generations of people who have all gotten a view of the Earth from the orbital spot there, how all the astronauts come back and they say they're completely changed. They say world leaders should have a minimum requirement of being able to view the Earth at some point in their lives from this because it's such a shift in your perspective on the world. If you have multiple generations of humans who have been able to view the Earth in that perspective, guaranteed you're going to have a change in the human nature after just a short couple generations.
That's
you remember the way Carl Sagan put it? The pale blue dot. Goodness gracious. Do you remember the old Cosmos episodes before Neil? I mean, the real Cosmos.
When they were
Do you remember those?
Absolutely.
God, I miss that man. Do you remember
I prefer
his
connections with James Burke, but
the language he used? It felt as if it came from his soul. Do you remember? Anyway, all right.
Oh yeah, I can play that whole thing back in my head too. It was such an unbelievably poetic.
Every one of those episodes was special.
It was.
Sal, who are your? I want to hear your top scientists. Anyone else whose work is underappreciated or under reported on that you want to plug for us? Any?
Dude, again, I want to plug some podcasts because they're important. These are either physicists or doctors in material science, astrophysics, astronomy, and they're trying to do something new. Again, Demystify Sci podcast with Dr. Shiloh and Dr. Anastasia. By the way, her name pronounced Anastasia is Russian. It's a beautiful language. Pronounce it correctly. What's this Anastasia? What? It sounds almost like she's going under anesthesia. But anyway, so please kindly pronounce it right. So I think she doesn't mind being called Nastia. That's like a nickname. Like I'm called Sal or anyway. So Demystify Sci podcast. Ashton Forbes, please, dude. He is this guy should have been he's definitely a good investigative journalist. Jeremy,
had him on the podcast last week.
I know you and him should cooperate on your research and stuff.
We have to have you, Sal, and Jeremy, and Ashton back on and bring together also Bob Grenier.
Listen, I promise. I'm making a solemn promise. I will come on this podcast as long as you want me, and as long as these guys don't say that you stop or and for no other reason that I have a 11-year-old to raise. So her future is far more important than mine. I've eaten my corner, my piece of bread. I've had my anyway. She is what matters to me. So the bottom line is again. Oh, don't forget Jay Anderson, right? Project Unity, and Kurt Mongo.
Yes. Yeah.
Theories of everything.
Here, I wanted to throw out.
Don't forget Tim Ventura interviews, dude. This guy had Lord Martin Rees on, bro. I'm talking about Lord Martin Rees, not. You know what I'm saying? Anyway, I see what he has to say about the future of civilization. It's not exactly a happy space, but anyway, you know what I mean. Like he sees.
I watched your interview with Tim Ventura about 3 times last night, Sal, and I've got 4 pages of notes from it as well as from the Ashton Forbes. So I'm gonna have to do an episode with you just on those because my God, are they worth watching?
He's a really good dude. Tim is a really, really good dude.
Also, check out
all you guys have a lot of great. I really applaud. I admire what you do, and thank God you guys exist because this is what I'm talking about: American ingenuity, American creativity at work. So bravo. This is for you guys, AlienScientist and APAC. Bravo. So. You guys are absolutely amazing. Thank God you exist. You guys are the future. That's the truth. Look at me. This is it's not like that I could dye my hair and look younger. Still, I'm of a certain age, but as long as I can say certain things and bring to just a little bit of incremental progress, I will. Just as long as I'm not there to, unfortunately, I gotta say this, and it pisses me off because there should be no enemy when it comes to Homo sapiens sapien. We are one freaking species, brothers.
Culture determines.
We gotta come together. We gotta find a way for unification.
That was like the perfect wrap up, man. You should just leave that go
unified field theory without unified physics, right? You have to bring all the physicists together to get unified fields.
So if there is a physical superforce, why not a social superforce to unify us all? Anyway, that's just an idea. To Jeremy, thank you very much, brother, for having me on. You're prince. You're prince among men. So thank you.
Thank you, man. I have some amazing friends. You guys are, I couldn't ask for better, man. You guys are awesome. And it's just great to have so many really smart people that have come together to give different perspectives and just try to, pick out, whatever we can from this that's useful and then find out what isn't. And you just try to move this whole thing forward, man. And
but again, we move on with no derision or ridicule toward the people that quote unquote, that we think have so-called failed. Don't use language of that nature.
There's no shame in being
there's no failure when it comes to trying. The real failure is not to try at all.
Yes.
Period. Right, Jeremiah?
Yes. That's absolutely it.
That's right.
Stick it on the lab bench. Find out what happens. If it catches fire, oh well, you try again.
What happened? Like no sisters. I mean, I see only brothers here. No, we gotta get some sisters.
Oh, we got sisters.
We have some sisters. It's because it's Sunday, Friday night. The girls join, right?
Now, there's a lot. We have a lot of very bright ladies in this community too. They're not here today, but we should do a whole lab show because
I mean, the ambiance changes completely, man. It's like between you and I. Thank God for women. Because I tell you right off the bat, it's their compassion. It's their
something to keep us guys on the straight and narrow, right?
Otherwise, excess testosterone can. I think I can say that. You know what I'm saying?
Oh yeah, I know exactly.
Certain unpleasantness.
She's here helping me today. She's just not on the show, so just saying.
That's right. And Michael had his daughter, because I heard her. Dude, teach her well. She's got a great father. Teach her everything you know, bro. So anyway. And Dave, the physicist, you're the man. For real, man. One of your slides, just one of your slides. God, you're really good. Keep on going. I think one day, who knows, maybe when you become chief editor of Physical Review Letters, I have a chance. But maybe with that, they say, man, this is not bad. Come on. just
yeah, we can talk more.
So let's talk after the show. We're on the hour here. So it's about
let's wind it down here. Guys, thank you so much for watching.
All right.
Yeah, stick around. We'll talk in a minute.
Bernie.
Yeah,
you do some awesome AI art, man. Yeah.
Thank you. Do you mind putting your email in the private chat and then I'll email you?
I suck at that stuff. He knows it. Just ask Jeremy.
Okay, I'll get your email.
Get in touch with me.
Okay, because I'll put together an episode with Joseph Farrell and Walter Bosley with you as well, sir, if you would like that.
Oh, I would love. Oh my goodness, I would love that. But listen, I hold both of them very, very high esteem, especially Dr. Oh my God, Dr. Farrell. I have so many of his books. Anyway. The one, Dave the physicist, check out Dr. Joseph Farrell's Secrets of the Unified Field. Check that one out. Just, I know and all that, but trust me, it'll give you some ideas. You're a very smart dude, brother, and this math that, will give you rites of passage. So why not use the philosophy of great physics to propel you even further? If you can prove it mathematically, your homeboys can tell you no. But anyway, all right, I digress.
Amazing episode, man. Hey, thank you so much again for joining us, man. You're the real deal for coming on here and putting up with this, because this is like
all you brothers. It's all you. I came out because I really hold you in admiration, and I think you are the future. You really, because you don't do this for money. You don't do this for power. You don't do this for greed. You do this because you want to. You really want to advance civilization. So my hat off to you.
Much love.
Love,
hey,
return, brother.
May the
Oh,
super force be with you.